We got a lot of round stuff done in the previous video, and you had 2 assignments, the piston and the cylinder. And now we're going to do some rectangular stuff. Looking at this 2 o'clock cylinder standard, the 6 and the 10 are very similar. We kind of went over that before. The shoulder depth up here is one of the variables that changes. And then the 6 o'clock is a little bit longer and it has some holes in the bottom. But we're going to draw the 2 o'clock, the 6 o'clock, and the 10 o'clock individually, starting from scratch each time. Part of that is repetition. You want to build a muscle memory for making things. You want it to be fast, and the only way you're going to get fast at this and create that muscle memory is to do it. I'm going to start a new part. Oops, I've already got a new part open. I just need to start a sketch. Front plane. Right now it doesn't matter. What should be your approach here? Well, there's many different ways to approach a part. Typically, you want to sketch the most complex profile that you can and get that extruded. That's usually a good approach. And that would work in this, even the direction that we're going to go with this. We're going to use this to enter into the world of configurations, and we're going to use that as a feature rather than a sketch. But I would probably, if I was just drawing one of these, I would probably sketch this view here and extrude either toward me or away from me or mid-plane, and then drill the holes and be done. That's one way. I'm going to show you another way. It's not better or worse, it's just how I show it. There's a million ways to do things, and you have to pick one, right? So I'm going to show you another way, and I'm going to start with a rectangle. That rectangle is going to be coincident with the origin. You always want your part coincident with the origin in some way to make it fully defined. And then I'm going to smart dimension it. And we are 1 inch wide. And we are 2.6 tall. I'm going to extrude that. And I'm going to do a mid-plane. And we want, it's 1/2 inch thick, so 0.5. Now we have our solid, and I'm going to cut the shoulder, the 360 thousandths deep shoulder. So I'm going to get normal to this in my view orientation, it's a good habit. And I'm going to right click on this surface, I'm going to select sketch, I'm going to go back up to my corner rectangle, I'm going to click the corner, making sure that I get that orange dot so it's coincident, and then I'm coming over here and I'm gonna left click again when I show my coincident icon, and then I'm gonna smart dimension from the top to the shoulder, and my plan set says that is 650 thousandths, and I'm going to extrude cut down from here, probably not that far. We're going to go down 360 thousandths. So I'll change that to 0.36. Click OK. Okay, we have our feature. I'm going to get normal to this face. And we are going to drill some holes now. We're going to be drawing specifically these number 1032 holes. Hole wizard. In type, these are straight tap. It's not a bottoming tap. We're going just a tapped hole, and these are number 1032. Oop. And these are not blind. These are through all. Okay, now positions. I'm going to hover on this upper line until I get my midpoint. See that blue dashed line? That means I'm at the midpoint. And I'm going to just dump 2 holes approximately where they go. And I'm going to smart dimension them. The top hole is 0.35 from the top. And then the dimension that you are given is that the bottom hole is 300 thousandths from the bottom. It's a really bad idea to use 2 datum edges for your holes. You want to dimension this bottom hole from the top edge. Now a lot of times you'll get dimensions off the bottom edge, but what that means is that the tolerance for the length of this part all of a sudden becomes hypercritical and your part cost goes up. So let's figure this out. We're 2.6 minus 0.3. We are 2.3 from the top. Let's dimension that. Okay. What we can do is we can smart dimension from an edge. I would probably not do this normally. I'd probably put a center line on there. Okay, now that's fully defined, but this one's not. So we could do another thing. We could dimension this hole, or we could go into add relations. Click this hole and this hole and say that I want them vertical. Now I'm fully defined. This is black because I just told it that this hole is in line with this hole, and I gave this hole a dimension. And that's kind of nice. Imagine if I had, 150 holes in a row, I could define one and then click on all the others and say, hey, just make these the same as that. Click OK, and we have two number 10, 32 through holes. One of the frustrating things with Hole Wizard is that you can only drill one size hole per instance. So these number 50 holes we have to do separately, and because one of them is through and one of them is stopped, we have to do them in two different instances. It's going to be a lot of Hole Wizard, but that's good. Repetition is good. Go Hole Wizard. We want just a hole, and I don't want all drill sizes. I want numbers so that we can just sift through this a little bit faster and go up, 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 up. Larger the number, the smaller the drill. All right, and this is through all, so we'll do the through all one. We'll do the one on the right. So I'm going to go to positions. I'm going to select this face, and I'm just going to dump it right there. And then I am going to draw a center line. And I am going to dimension off the center 60 thousandths for this. And we are 800 thousandths from the bottom. Probably be smarter to dimension it off the top. So if we're 2.6 and we're 80 thousandths, that's what, 1.8 from the top? Keep selecting a line or a point. There we go. What did I say? 1.8. That's through. Great. Let's do it again. Hole Wizard. By default, everything's going to be what I want except for the depth. So it's number 50. It's not through all. It's blind, and we are going to go halfway through, and this is half-inch material, so this is going to end 0.25. In positions, I'm going to just select this. I'm going to dump it right there. Draw a center line again. And again, a lot of this is to establish muscle memory on doing these things over and over and over again. And we're 0.06. And we are 1. Okay. We need a 5/16 18, which is a really large hole compared to what your plan set shows. So, Hole Wizard. And this is a tapped, straight tap hole. This is a bottoming tapped hole. And we want, that's bottoming is what we're showing here. I want a 5/16 18. After a certain point, you get to quarter, they go fractional again. 5/16 18, so 5/16 nominal outside diameter, 18 threads per inch. If you've taken intro to metals, you should remember that. Okay, and I don't really know how deep to drill this, and that's okay. We're just ignore how deep it is. We'll go back and we'll edit that. Let's go to positions. We're going to select this face, And we're gonna, because I did mid-plane, my origin's in the center, so I can snap this right to the center. That's why I did mid-plane. Okay, and I know that this hole is the same distance from the top to here as the number 50s, because it bisects one of them, and that was 1.8. But I don't know how deep. I know that I don't want to drill all the way through there. So let's go back to type. And let's scroll down and look at our depth here. It's blind to a certain depth. Well, there's an up or a down arrow here. Let's click it. Let's zoom in a little bit. See what we got. See if you can see that. See the point of the drill bit? I want this port to be as free-flowing as possible. I might make that go a little deeper. Oh, one click of that and I bisect my other one. These are both intake and exhaust ports. So I don't really want to do that. Let's look at, we're at 0.3915. Let's try 0.4. Let's see what that looks like. That looks pretty good. Maybe 0.41. I just want there to be a smooth transition. Let's call it 0.41. Let's see what that looks like. I'm just going to hit OK. And then we're going to zoom in on this and look at it. That's a nice port. It's completely open for this number 50 hole and then blends into this. That's pretty good. We could tweak it a little bit more and make it perfect, but it's not really about perfection here. It's just seeing that I didn't know how deep to drill this hole because the drill bit has a point on it. And so I placed the hole, I dimensioned it exactly where I wanted it, then I went back to my type tab and I monkeyed with the depth visually and got it close and then moved it, you know, some tenths and some hundredths to get it where I want it. We don't have material. So let's right click it, let's edit. This is aluminum, not steel, it's aluminum. 6061 T6, thermally aged. Apply, close. There's my material. File, save as. And this is, this is going to be, I'm not quite sure where you're going to save your things. I'll make a folder in Three Sisters. Actually, I'm going to keep this out of Three Sisters. I'm going to make a new folder. This is something you're going to turn in, and I'll just call this assignment. Assigned parts. And we'll call this is the 2 o'clock in assigned parts. All right, I want you now to do the 10 o'clock and the 6 o'clock, and I want you to drill the holes in the bottom of the 6 o'clock. That's your assignment. The 2 o'clock, the 6 o'clock, and the 10 o'clock.